Okay, today I'm going to show a technique named TS transform. It's a very cool effect um, for filmmaking. It's used in filmmaking like 20 years ago, and it's very interesting effect. And it's easy to implement it. So I just use Houdini and use add some code here to apply this, and I can show you some effect I have already made. Where is it? Yeah. Yeah, this is a text transform effect, and this is original video. This is another video that uh, no text transformed. This is the original video. Okay. Yeah, this is another one. Yeah, basically I'm going to introduce how to implement this. Just this. Okay, this is the website of text transform techniques. You can search text transform in Google. You can find this website, and in this technology, it will introduce these techniques. It's quite simple.
TX flux
Yeah,
and
I
ruler.
will use this video to help me to tell.
TX transform is a new film technique which reverses the time and space axis. Depending on the type of shot, the result of a TX transformation can seem either abstract or completely realistic. How does TX transform work? Imagine a flip book. This flip book is a three-dimensional rectangle and therefore a block of information. Normally, the viewer passes through this block along the time axis, which creates an illusion of movement. Imagine that this block is cut into slices and flipped through from the side. Each of these new images is perpendicular to time. Left is before, right is after. This is the basic principle of TX transform, a new technique which transposes the time and space axis. What is shown in a TX transformed film? One might expect that it makes no sense to the viewer, but this is not the case.
Yeah, this is some effects made by TS transform, and you can see the technique is very simple. Just normally we go through frame by frame, is passing through time, but by TS transform we just kind of transpose time and this space, like most time is a x-axis. So basically every frame, this is every frame here, we just go through the space instead of time. And in the content of each frame is contained all of the time as a specific space. Anyway, it doesn't matter. It's just you can get this effect. Basically, this every frame is a TX transform effect. So yeah, I know at the beginning you may feel a little bit confused. you can think about it to or just watch the video, whole video to get more information. I will put the link there. It's not very complicated. Just basically the all the technique rewards the time and space to get this weird effect. Anyway, I will just introduce so much. So I will introduce how to implement this in Houdini. Use some simple code here, and yeah, don't worry about it. It's not very complicated. Yeah, basically, if you can understand this method, you just what we'll need to do is just we already have a video, and also the video is the sequence of images. So we just use these images like this here. This is our video images, and we try to get this images basically is how to say sample all of the images and to combine them to get the new images. So first of all, we need to have a video. So I clipped some video from a very good movie. This one. Yeah, because these techniques need some special camera movement and object movement, so you can get the design effect. So this video I pick has some subtle camera movement and also a lot of objects and human movement, so you can see the effect more clearly here. This is actually the effects after TX transform. So basically, the first thing you need to have is the sequence of images. So first thing, I use TX transform. I use Houdini tops, the PDG system. There is a node named video FF. This video extra images. So you can use the node to easily get images, extract images from video. And I collect all this video and set up some parameters and pass it to the COPS network. This is the images. I can show where is the images. It's very quick to extract images from video. Here is a show it. Yeah, this is the images you see, and you collect these images and you just use these images to sample here. This is a ROP node to basically execute the cop node here. So the cop node, the current cop node is this one. I just found this. I can write some code. Use this snippet node inside of this warp node. I don't know if there is some other ways to do it, but I think maybe there's some ways. Anyway, this worked for me, so I just introduced this way. I can write the wax in this snip node. Basically, what I'm going to do is to sample to read pixel from those images I just showed. Okay, I just reopened my Houdini and adjust the UI size, so I think this time you can see the code clearly. So basically, what this does is to first we get the path of the images and the input frame count, how many images we have, and how many images we want to get the transform effect. Basically, this decides how quickly, how fast, or how slow the effects goes through. Like if the frame is long, so it will go very slow. It's short, it will go fast. So we can adjust it to use parameters. And all this is some format to, because here our images is this, how to say, for numbers to show the to represent the frame count. So use this to replace this number, and then we can get the image name and suffix, and basically the his image name is a frame, whatever the name you gave, and the suffix name. So we get this, and then because we need this to combine to get the final image name, so we can sample that, sample the texture, and then we calculate the frame, which image we need to sample for each pixel on the screen. So from the instruction here, we know that this is our normal video, right? With the normal input images. Basically, it's from time, goes through the time axis. But what we created is this sequence is go through the space, go through especially the x axis, and so each image each image is the x axis is the time and the y axis is the same. So yeah, so we need to generate this image. So how to do it? Basically, we need to know each pixel, which sample, which input image we want. It is decided by the new image's x axis. It's the time axis. It's the new image is the time axis is its x axis. So yeah, we need to use like this pixel here. Is it because the x is u with u? The x is like in the middle. Is so we need to use the middle frame of the input images. So it's decided by the x value. So here we use input frame count, how many input frames images we have, to divide the resolution, how many pixels we have in x axis, the output image, and divide this and multiply the current frame, the current pixel in x axis. So we get the frame number. Now it's a float. This +1, and just to make it precise. Yeah, I don't go to the detail. Anyway, now we get the which frame we want, but now it's a float because the frame count may not equal to our resolution. We better make it equal, but sometimes we just don't if we don't do it deliberately, so we don't have the equal number, so it's a float. So now we can get the float fracture, and also the it's called fracture. Fraction, and we can also calculate the floor of this float, also the seal of the float. So I use this fraction to lerp the frame and next frame, and we have the pre-frame and next frame index, and we can use image name and suffix to get the prick pass and next pass. To prove it, I can. This is my debug mode. Yeah. Here, it will pop up a dialog to show. Yeah, this is what we get. The pre-pass, we just calculate in this 100 ix is 100 the 100 pixel at x 100 at x equal 100. So the pixel the images we're using frame 53. Anyway, after we get this, we can this we get the frame we need, and before sample it, we need to calculate the U and V. The UV we need, and V is the same with the before. We didn't change the height, basically the height of the y-axis. But the U, which pixel we want to sample from the input images, is actually current output images, output frame count. That if it's beginning, we sample the this side, like the U is the right side of the input images. If we generate the last frame of output images, we sample the left side of the input images. So the sample U is calculated by the current frame. It is F is current frames. Like now is 153, and also this plus 0.5 is to sample the center of the sample, and to divide our output frame count, so we know the UV we need to sample, and we use this UV to sample the input images to get this color, and we use the fraction to lerp this color. Basically, this is just to sample the texture, and after get the color, just assign the color to this pixel. It's done. That's basically the code. And yeah, by doing this, we can get the text transform. It's so simple. Yeah, and this is not important. I didn't use this actually. So this we can get this output. What else? Yeah, this is I try to use Houdini to encode the video, and here it's to clean up. After generate the video, we just delete all the images we generate in the process. Okay, I think that's the whole tutorial. I It's very simple. Okay, that's it. I can put a set in the description. If you want to know exactly how to do it, you can check the file. Also check the website to know how to do it. But these techniques really need to use. It really depend on your input videos. It's very you need to deliberately design your movement of camera. But yeah, but it really it can get some very interesting effects if you put input smartly. So it's a very interesting tool I found, and I hope you find this interesting as well. Thank you.